Hello everyone, and welcome to this video introducing theoretical probability, or I should say reviewing some things about theoretical probability and discussing compound probability.
And I know this isn't my usual intro, but I couldn't help but share. There's ducks in our pond! I just think that's cool. Yeah, that's it. I just wanted to share that with you. So, enjoy this video. There they go.
In this video, we'll focus on solving for theoretical probability, meaning we won't have necessarily experimental data to go with each problem, but we'll be able to solve the problems. A few terms and definitions for us today. First, just a reminder that our probability is always a chance between 0 and 1. Oftentimes probabilities will be referred to in percents, but they can also be decimals. A theoretical probability is based on some kind of odds. They must be given to you, or you must be able to understand that the odds are broken down in an even way. A complement is the opposite of a given probability. So if I want the probability of not a 2, then I want the probability of the opposite of rolling a 2. Now this last one on compound probability is important because if you have multiple events that you're trying to test for, say rolling 2 dice, then you are going to have to multiply the probability of each 1 dice to make the final result. The key factor here is that you will have to multiply multiple events together. For a simple example of theoretical probability, we can look at the probability of spinning more than 3 in the game of life. Well, more than 3 are the numbers 4, 5, 6, 7, 8, 9, and 10, and that's 7 possibilities out of the spinner. We are making assumptions here, like that the spinner is a fair spinner, and that the sections of the spinner are all of equal size. On average, it rains 4 times in the month of March. Well, since March is a 31-day month, our average probability that it rains on a given day in March is 4 out of 31. What you might not have expected, though, is that we're asked what's the probability that it will not rain on St. Patrick's Day. This is an easy thing to miss, but once we do see it, the chance of it not raining is the opposite here. This is a question asking us to solve for the complement of a probability. My answer will be 27 out of 31. This is an example of both complementary probability and compound probability. We're going to spin the spinner twice. What is the probability that neither spin is blue? Well, so this is a coded version of a complementary probability. It's not blue. 12 of the 16 sections are not blue, which simplifies to 3/4. However, I'm going to spin this spinner twice, so I'm not just going to have one of these 3/4. I have 2, and since compound probabilities multiply, I have to multiply these 2 fractions together to make 9/16 as my final answer. To sum up the notes here on theoretical probability, your probabilities, either as decimals, fractions, or percents, will be between 0 and 1, and they're made up of the desired result out of the total number of possibilities. When you're doing a complement, you need to consider the opposite of that event, and a compound event always multiplies the separate events together. I hope this has been helpful. I wish you the best of luck. Stay happy and healthy, and I'll see you in the next one. Bye!